Hello and welcome back. Up to now, we have seen that whenever we run a program, it starts from the first line within the main function, right? But if I say we can change the order of execution, would you believe me? You have to believe because C is full of surprises. The topic that we are concerned with today is preprocessor directives. Again, it has two parts, preprocessor and directives. Now we all know what is a directive. Directive is like a command or an order that we give for execution. But what is a preprocessor? It's a new term, right? To understand this, we need to go behind the curtains. In front of you, there is a flowchart of whatever happens after you click the compile and run button until we get the final output in the terminal window. It all starts from here. We have written something in C language and that is our source code. We have saved it with a file with extension .c that makes our C program. Now we are running the program. The first thing that is checked is whether any preprocessor directive, or in short form PPDs, are present or not. If any such directive is given by you, we will see how to give PPDs in our program. Don't worry about that. For now, just assume that there is something called PPDs. We will see the detailed structure of how to write the PPDs, how to use them. So coming back to the flowchart, if any PPD is found, then it goes to a program called preprocessor. The preprocessor executes whatever command you have given, whatever directive you have given, and then the control goes to the compiler. If your program did not have any PPDs, it directly goes to the compiler. So up to this, what is the conclusion? Any pre-processing task happens before compilation. Correct? Next, the compiler, as we know, it checks for any grammatical errors that we have made in the syntax. If no such errors are found, then it generates something called as object code. Now what is this object code? The syntax, the functions, the loops, whatever we write in C language is a high level code that is not understandable by machine. So the compiler converts that high level code into a low level one which can be understood by the computer and it is easy to execute. Now in some cases the object code is itself executable, but usually we take some library files as include statements, right? In those cases, without having a communication established between our program and those library files, we cannot execute it. This task is done by the linker. So what is a linker? Linker is again another program which takes the address of the files that you have called, like the standard library.header file you have called, right? The standard input output header file. All these files are stored somewhere in the memory, so they must have their own addresses. It is taking the address of those files and it is linking this with our object code to create the final executable file that we all want to see. And these are a bit complex tasks. There are variations in it. We can either take the file physically and link it with the object code before creating the executable, or we can just take an address of the file without physically taking it and then link it with the object code. These are some static and dynamic aspects of linking. So all these complex processes happens inside the computer before we get the final exe file which we run and get the output in front of a screen. If you find interest in this and want to dive deeper, you can refer to operating systems and compiler design. There you will know in detail what is a linker, what is a compiler, what is a preprocessor, how they are connected, how these processes are scheduled and together they are synchronized. But that's definitely not what we are going to deal with here. This is something completely out of scope of this course. Just to have an idea of what goes on inside the computer, we have referred to this flowchart. If it seems headaching to you, what is linker, what is compiler, what is preprocessor, all these things, then no need to worry. The major takeaway from this slide is just to know one single fact: preprocessing happens before compilation. Only this thing should be clear in your mind. That's enough. Let's proceed. Now we will know in how many ways we can implement these preprocessor directives. So to figure them out, let's go to the editor. So here we are, and you can see in the very first line we have a preprocessor directive. The moment we see the hash symbol, we understand that it is a PPD. What kind of PPD is this? It is a file inclusion directive. So by writing this line, which we have been doing since the very first program, we are ensuring that this header file stdio.h will be included before the processing begins from main. That is what we mean by a preprocessor directive. The direction is to be carried out before the compilation begins from main. What is there in the second line? It is another type of directive identified with hash define. We call it a macro. And macro's concept is very simple. Like here we have a nickname limit for this value 5. Macro acts as a text replacement. Whenever in the code you will require this value, you can replace it with its nickname. Now for this tiny program you cannot understand the utility of macro. However, in practice, when you will be dealing with large programs and arrays, and we know the size of the array like 10 or 15, we can create a macro for storing the size and then use it for all future occurrences. Let's run it. This is what we get from the printf statement, which is correct. In the second program, we can find an alternative use of macro. We can imitate some functions using a macro like this. Just give a parenthesis with all the required parameters after the name of the macro and define its behavior. Here the function is area, that's why the behavior is length into breadth. So it will calculate the area of any plot if we pass the length and breadth as the parameters shown here. So within the main we have taken the length and breadth and calculated the area using this macro by passing L1 and L2 as the parameters. As rightly said, you can follow the comment. Basically, it's just an automatic find and replace mechanism. So the moment we write this line, the functionality defined by the macro will be invoked. L will be replaced by the value of L1, that means 10, and B will be replaced with the value 5. So we will get L into B, that means 10 into 5, 50. Let us check it. Fine, that's the correct answer. In the third program, we have discussed a problem of macro. The structure is same as before, only difference is how we pass the arguments. Since it works like a cut and paste or a find and replace mechanism, if we pass the arguments in this form, instead of giving a single value, we are passing an arithmetic expression. It can be addition, multiplication, subtraction, whatever. Then what can happen? Pause the video and think for a moment. Let us just pick up these values and put it into this formula. We get L1 plus L2 into L1 minus L2, right? This is what we get. Here L1 is 10, so 10 plus L2 is 5, 5 into 10 minus 5. This will give us 10 plus 50, that means 60 minus 5, which is 55. Let us check the output. That's what we are getting, 55. But do you think this is the correct answer? Was this our intention? No, this was not what we intended. We wanted L1 plus L2, that means 10 plus 5, so 15 as the length, and the second parameter would be 10 minus 5, that means L1 minus L2 will give us 5. So 15 into 5 will give us 75. That was our expectation. But we are not getting 75, we are getting 55. The main reason for it is blind copy and paste. If we have given brackets here, then the problem would not have arisen. Because of not giving brackets, the arguments was just copied and pasted here, and that caused this problem. Following the bedmass rule, we know that multiplication will come before addition or subtraction. So L2 and L1 was multiplied, which we did not want to happen. This is the difference between a macro and a function. A function is intelligent to understand that first do this calculation and then put the value into action. But macro is not that intelligent. It will just copy as it is. So if you do not have bracketed your arguments, then you might get unexpected answers. So to fix up this problem, we will bracket the arguments. Now it should work fine. Yes, so we get 75 this time, which is the correct answer. In this program, we have done a new thing. We have included our own header file. Remember in the last class, we have made our own data type, the structure. Today we have made our own header file and included that into our program. Isn't that awesome? First of all, there are 2 points to note here. How to include a user-defined header file. Add.h is not provided by C, it is made by me. I will show you how to make a header file. But then first of all, the syntax is to use double quotes whenever you are including a user-defined header file. For system-defined header files, we use the angular brackets. Now the second point, how to make a header file. So for that, just make a new source file, type whatever functions you want to include in your header file. I have made a simple add function. Now let us make a subtract function. So int sub for subtract. Suppose it is taking two arguments, int x and int y. This function will return the difference. So return x minus y. Let us make this function more interesting. We want the absolute value of difference. So we will check if x minus y is a negative value, then return y minus x, right? So if x minus y is less than 0, is it? If it is, then return y minus x, correct? Otherwise, return x minus y. So let us rename the function as absolute difference. So abs diff. This is what our function is doing. Now, up to this moment, we have just written a simple function in C syntax. It is not a header file. To make it a header file, save it with an extension .h. So we try to save this file. We go to the desired folder, 23. Yes, and now we save it as absolute difference .h. This is very important, .h. The moment we save, it becomes a header file. Now we close this and go back to the program. Let us include the file that we have just created. So hash include, sorry, we do not write angular brackets. This is a user defined header file, so we will use double quotes for this. Absolute difference .h. Now we can use that function in our program because it is present in that header file, right? To add the second function, we will have another printf statement. So let us run and see. 5.6 plus 7.4 will give us 13.0, and here the return type was integer. The absolute difference between 3 and 12 is obviously 9, which is correct. Bingo! We have made our own personalized header file, included it into our program, and applied the function. How does it feel? Cool, right? One thing that you can logically inquire is why we are using a separate header file for just one function. We can directly make a function in our program and use it. What is the need of a separate header file? You are absolutely correct. In real practice, header files are made as a collection of similar type of functions. Like we have the string header file, which contains a bunch of functions that we use for string manipulation. Similarly, we have the standard input-output header file, which contains a bunch of functions only for input and output operations. That's definitely not just one function. There can be tens and even hundreds of functions within a single header file. Therefore, these header files altogether have a common purpose. Each header file is a compact collection of particular functions made for a particular task. This is going to be your do-it-yourself task for today. Make a header file of your own. Include different types of functions. Name the file as numbers.h and try to list as many functions as you can regarding numbers. Like we have addition, subtraction, multiplication, but these are very common and stereotypical examples. Try to invent some new functions. Like if I give a number, your function will give me the total number of digits it has. Let us take another example. If I give you a number, it will tell me whether it is a palindromic number or not. Now generally palindrome is associated with strings. However, you understand what I mean by palindromic number. If I reverse the number, it still remains same, like 101. Try to make a function that converts a binary number to a decimal and vice versa. We know how number system conversions happen, right? These are some interesting functions that you can make regarding numbers. That is your homework. After making such a header file, you will definitely gain confidence. Moreover, with these header files, you can personalize your coding experience. The functions that you are going to make is unique to you. These are not available to any other users in the world because you have made it. That itself is like a mini project, right? We move to the next program, and here we have a different type of preprocessor directive. We call it Conditional Compilation Directive. As the name suggests, there must be some condition. So we will be using if condition followed by else if, which we write as elif, and finally we have else condition. These are some of the directives that help us apply some conditions. What are the conditions? Here we can see we have defined a macro with the value 1. So whenever we write num, it means we are referring to the value 1. Using this hash if directive, we have checked whether num is equal to 0 or not. Here num is not 0, so this line will not be triggered. We go to the next line. This is checking whether num is -1, which is again wrong. Finally, this condition will be true and we will print a positive number. Note that towards the end we have written end if. This directive marks the end of this entire if-else ladder structure. So this is the end of the if, else if, else ladder. Let me correct this. It's elif instead of else if, right? So we run this and we get what we expected. Let's try with a different value like -5. This time the last condition was activated. So what did we learn from this program? This conditional compilation, I mean these hash if statements or hash elif statements, they can control which portion of the program is going to be compiled. Since the preprocessor works before the compiler, the moment this if condition is true, all the remaining conditions will not be visited by the compiler because they fall in the else category. Hence, we are basically controlling the movement of the compiler, right? It's really a powerful operation. What do we have next? This is another type of conditional compilation. It checks whether a particular definition is existing or not. Like here we have defined this macro number for the value 1. So currently it is defined and this statement will give true, so we will print it is defined. No problem with that. Automatically the other statements will not be executed. Moving next, we find this directive hash undef. It will undefine the macro number. So after this line, if we check for the definition of the macro, it is invalid. Now this statement is not triggered. So we go to else and print that it is not defined since we have recently undefined it here. Let's try this out as well. Clearly the output matches our expectations. In the first scenario we get it is defined, but after we undefine the number, we see it's not defined any longer. Proceeding to the last program of this session, we find a new directive. It falls under the miscellaneous category, and there are a variety of such other directives. Just as an example, we have taken up the Pragma Directive. What does it do? It can control the timing of the functions. By mentioning startup, we indicate that func1 is the function which is going to be executed before the main function. Since it is a preprocessor directive, it will have precedence over compilation. On the other hand, using exit, we want to state that function2 will be executed after the main function, just before the program ends. So here are the definitions of the two functions followed by the main function. The expected output is somewhat like this. First function 1 is invoked, then the main function, and finally function 2 comes into play. Unfortunately, this directive is not recognized by GCC compilers. Since I am working on GCC compiler, it will not work in my PC. If we run this program, only this statement will be executed because it is within main function. Let us try this. As you can see, we have only executed the line that was within main. This happened because we are working on a GCC compiler. If you work on some other compiler, then you may get this output. With this, let us have a quick recap since beginning. So this was the topic of discussion today, preprocessor directives. Then we saw what actually happens inside the computer after we click the compile and run option. Next we discovered different types of PPDs. Then I assigned you a homework. It's a do-it-yourself mini project where you can make your own customized header file as you wish, name it numbers.h or any other name which you like, fill it with multiple interesting functions or numbers, include that into your own program and play with them. Finally, we have a chart for reference. As I said, there is a variety of preprocessor directives, but the major ones we have already covered. So yeah, that's it. Meet you in the next class. Stay safe. Have a nice day. Bye bye.